Good morning, class. My name is Corporal Lucas Shadova, and today we'll be going over converting azimuths. Real quick, we're going to go over the risk assessment. The overall risk assessment for this class is low. Some things you guys need to be aware of are possible ceiling fans you may or may not have in your classrooms or homes once you guys get hit by any of the blades. If you guys have any hot liquids, such as coffee or anything of that sort, do your best not to spill those on you, otherwise you could possibly get burnt. Other things you need to be aware of are going to include tripping hazards such as electrical cables, backpacks, and other shoes that may be in your way. Just do your best to watch out for those, as we don't want any of you guys getting hurt. Remember that the Army is green, so reduce, reuse, and recycle when possible. Items you will need for this class are going to include a pencil, paper, water source, CAT card, and a 1 in 50,000 scale military map. So rolling right into it, like I said, the task for today is going to be converting azimuths. Some of the standards and conditions that we have in place for us are: you are a member of a squad preparing to conduct tactical movement, and you have been directed to convert azimuths in preparations for the movement. You have been given a 1 in 50,000 scale military map with a declination diagram, pencil, paper, and a magnetic azimuth, and a grid azimuth. Some iterations of this task should be performed in Mop 4. Standards: convert an azimuth into a back azimuth, a magnetic azimuth to a grid azimuth, and a grid azimuth to a magnetic azimuth, without error. There are no special conditions, no special standards, and the safety risk of this class is low. So, rolling right into it. Some things we need to be aware of as we start the class is that the north and south lines on the map, those indicate our grid north, while the north on the compass represents our magnetic north. So that's where we will be making our conversion from. The GM angle, which is the grid magnetic angle, which can be found on the map, is the angle we'll be using to make the conversion between our grid and our magnetic azimuths. So, performance steps. First step, converting an azimuth into a back azimuth. When converting azimuths into back azimuths, extreme care should be exercised when adding or subtracting to 180 degrees. A simple mathematical mistake could have disastrous consequences. So, jumping right into converting a azimuth into a back azimuth. One thing we need to take into consideration is whether or not our azimuth that we have shot falls above or below 180 degrees. So if the azimuth falls below 180 degrees, say 170, we would be adding 180 degrees to our azimuth to get the back azimuth. But say the azimuth we shot is above 180. We'll say it's 210 degrees. You are going to subtract 180 degrees from your current azimuth in order to get that back azimuth. Shooting back azimuths is probably the easiest of the three that we'll do today, but like that warning had stated before, it's can be extremely easy to possibly make a mistake. So, converting a magnetic azimuth, which is our compass, to a grid azimuth, which is the azimuth located on the map. First thing we're going to do is go ahead and look at the map. We're going to locate the grid magnetic angle, which the one we will be using is 9.5 degrees today, as well as we need to understand whether or not the GM angle is easternly or westernly, as that will impact the calculations we make today. So, converting a magnetic azimuth to a grid azimuth. Go ahead and look now on the maps, figure out whether or not we have an easternly and westernly. On my diagram here, shows that we have an easternly magnetic grid magnetic angle. The way you can tell whether or not it's easternly or westernly, it states on the map, but the grid magnetic angle will either fall to the east or the west of the grid north. So on our diagram, we have one that falls to the east, so we know it's an easternly grid magnetic angle. On the flip side, if that GM angle was to show up on the western portion of the grid, we would know it's a westernly angle. So moving forward with making calculations. Apply the mathematical formula to convert a magnetic azimuth to grid azimuth. So you are going to add an easternly GM angle to a magnetic azimuth to obtain the grid azimuth. Whereas if we had a westernly GM angle, we would subtract our GM angle from the magnetic azimuth to obtain the grid azimuth. So, since we have the easternly, let's say our azimuth is 190 degrees, we would add our 9.5 degrees to give us the grid azimuth of 199.5 degrees. But say we had a westerly GM angle, we would subtract that 9.5 degrees from our 190, which would give us 180.5 degrees for our grid azimuth. Moving on to the next task, convert a grid azimuth to a magnetic azimuth. So you're going to do the same thing that we did on the first conversion. You're going to locate that GM angle, which we have the same GM angle that we used on the last task. So that 9.5 degrees, but now the math that we'll have to use on this one is going to somewhat flip. So on the last one, we went ahead and added the easterly GM angle to obtain our grid azimuth, but now we're going from grid azimuth to magnetic. So we are going to subtract for the easterly GM angle. So if we have that 190 degree azimuth, we're going to subtract the 9.5 in order to get that 180.5 degree magnetic azimuth. Whereas if we have the westerly GM angle, we're going to add the 9.5. So if we have 190 degrees and we have a westerly GM angle, we're going to add the 9.5 degrees to give us 199.5 degrees. Right now, we're going to go ahead and move into a practice scenario, which the practice scenario is going to be extremely similar to the tasks and the diagram that I just used. So the azimuth you will use is 190 degrees. Looking at your map, you can tell that you have an easterly GM angle of 9.5 degrees. I want you guys to go ahead and make the conversion to grid azimuth and magnetic azimuth, as well as go ahead and shoot a back azimuth. So right now, I'm going to go ahead and I encourage you guys to go ahead and pause the video and take as much time as needed. Try not to go over 10 minutes if you can, but go ahead and get some practice in, as we will be evaluating how well you guys can perform this task here at the end of the class. So now that practice is done, I'm going to go ahead and restate the task, which is converting azimuths, and the standards and conditions that I have laid out, as we will be evaluating you guys and see how much information you guys retain from this class. So, conditions. You are a member of a squad preparing to conduct a tactical movement, and you have been directed to convert azimuths in preparation for the movement. You have been given a 1 in 50,000 scale military map with a declination diagram, pencil, paper, and a magnetic azimuth and a grid azimuth. Some iterations of the task should be performed in Mop 4. Standards. Convert an azimuth into a back azimuth, a magnetic azimuth to a grid azimuth, and a grid azimuth into a magnetic azimuth without error. So, for the evaluation, we're just going to be going over those three things that we discussed: converting the azimuth into a back azimuth, which was the first task we went over at the beginning of the class, converting a magnetic azimuth to a grid azimuth, and then converting a grid azimuth to magnetic azimuth. So, just so you guys know, if any of the PM has failed, the evaluation is over and we will have to retrain you guys. At this moment, I'm going to go ahead and ask if you guys have any questions. If there are no questions, we're going to go ahead and perform a police call, and I'm going to do a review of the draw. And at this time, I'll be requesting to close out the training site. Thank you.